46. Autosomes means you need to write only 44. Next, ABO blood group system is discussed that, as sir might have discussed about the multiple allelism. That is, a gene, I gene, information gene is responsible for that. It will be having a human leukocytic antigen. This is going to determine. So here ABO blood grouping system is because of multiple allelism. Okay. Next, hemophilia is more common in males because it is a recessive character carried by Y chromosome, dominant character carried by Y chromosome, dominant trait carried by X chromosome, recessive trait carried by X chromosome. Generally, hemophilic patients, it is a recessive trait because the female will be having two X chromosomes. If one is recessive, one is dominant. So dominant will be dominant over recessive. As a result, females hemophilic patients are how much percentage? Female hemophilic patients are 0.6. Once check. Textbook you will get the answer. Is the female hemophilic patients are there or not? First. Huh? No. Generally nil. Male, what is the percentage of male? Not male. But males can be generally possible of hemophilic. Next. So answer can be the D option. Recessive trait carried by X chromosome. Next, in Down's syndrome, a male child, the sex complement is, already you know the answer is male means X and Y. But here the Down syndrome is related to additional chromosome of 21 trisomes. That is 21 triple A will be present. So you write the 221 AAA. But as per the question, your answer is male means XY only. Next. Going on to the 24th question. Multiple alleles control inheritance of phenylketonuria, color blindness, sickle cell anemia, blood groups. Phenylketonuria. Yes. Phenylketonuria is a Mendelian disorder. Mendelian disorders mostly are autosomal disorders, and this phenylketonuria is because of phenylalanine dehydrogenase enzyme deficiency. Color blindness, it is a sex-linked recessive trait autosomal disorder. Sex-linked. Don't be nervous. A man of A blood group marries a woman of AB blood group. Which type of progeny would indicate the man is heterozygous A? A man of A blood group. A person, okay, father is going to marry and is having the what blood group? A blood group. and mother is okay. Father is okay. Mother is okay. Father is A. Mother is AB. And these are going to get the child according to the Venus. You can see that I A B I A B or IA and IB. Okay, I the possibilities are IA. Okay, you can have this data, but here the question is a person is in a group means the possibility of that person is IA. Two autosomal chromosomes. Here the person, the female is IA and one more gene carrying IB. Now, so if they get the sons, who is going to be shown as a heterozygous condition? These get the child. In these childs, who is going to be the heterozygous? Means, okay, we assume that, so here both are dominant. Here also dominant character only shown. Dominant character only shown. So there is a possibility of mostly getting either dominant IA, okay, one possibility. The second possibility is IB. Third possibility is IAI. The fourth possibility is IBI. Fifth possibility is I and I. Means nothing but O group. So here who can be the heterozygous? Means person may not be present, but it can be shown because of heterozygous condition. What can be that? Go to the multiple allism. There, that table. That table, madam. What can be the yes? Find out. Which type of progeny would indicate the man is heterozygous A? In this, you need to find out that right. So in this man here, the possibility can be this. One more possibility is also there, that IB, but this is recessive. Okay. So here the man indicates that the progeny going to indicate the father character heterozygous condition is B. Right. An organism with two identical alleles means genes is identical. Homozygous. It may be recessive or dominant. Anything. It is a homozygous condition. An allele is dominant if it is expressed in. What is dominance? You would have learnt law of dominance, law of segregation, law of independent assortment. A gene which is expressed in consequent generations is called as dominant. A gene which is not generally expressed in most of the generations is recessive. A gene which is not expressed but which is a component of a system is heterozygous. Heterozygous. Next, in humans, 45 chromosomes or single X abnormality causes Turner syndrome. Remember as Tuxo 45. If you remember this, okay. Turner syndrome, one X chromosome, 46 chromosome is absent, only 45 chromosomes are present. So it is Turner's syndrome. Down syndrome, 47, 21, triple A. 41, 47, 21, triple A. Next, Klinefelter syndrome, 47, 44 plus XXY. Okay. Next. Okay. KFC chicken in Mumbai. KFC EM47. You remember that. Klinefelter syndrome. Female characters in males. 47. That is 44 plus XXY. Okay. Turner syndrome. Tuxo 45. 44 plus X0. And okay, Down syndrome. Down 47, 21, triple A. So you remember this, you can answer most of the chromosomal disorders. Next, sex is determined in human beings by ovum at time of fertilization, 40 days after fertilization, 7 to 8. Genital differentiate into fetus at the time of fertilization. Right. Already you know that mother shares 22 plus 1 X. Father shares either 22 plus 1 X chromosome or 1 Y chromosome, any one. So it is at the time of fertilization. Of a normal couple, half the sons are while half the daughters are carriers. The gene is located on half of the sons are hemophilic while half of the daughters are carriers. The gene is located on obviously X chromosome. Father is hemophilic or not here? Father is hemophilic. Next, if a trait passes from father to all his daughters but none of his sons, the trait is, if the trait passes from father to all his daughters but none of his sons, the trait is autosomal dominant, autosomal recessive, sex-linked recessive, sex-linked dominant, because it is passed to all of his daughters and not sons, because sons are having only one, and it is Ollenro type of sex determination in that particular case. Next, 32 question. So there are two symbols given in a pedigree. represents what? That symbol is an indication of, that is not there in the book. There. That symbol is not there in the representation of the pedigree analysis. Sorry? In pedigree represents what? Dizygotic twins, monozygotic twins, either of two sibling brothers. In the textbook it is not there. Twins only, they are twins only. But what type of twins? Monozygotic. Okay. Okay. Here that symbol indicates not monozygotic, it is dizygotic. Okay. So it is not monozygotic. Monozygotic means from the same it can be divided. Here the symbol option is showing two different zygotes. Inheritance of skin color in humans is an example of codominance, polygenic inheritance, point mutation, chromosomal aberration. Codominance means two genes dominate, showing the dominance at the same time, that is multiple allelism, blood groups. Polygenic inheritance means when more than two genes are responsible for a single character, that is called as polygenic inheritance, like gout, color of the rats, skin color of the cows, skin color of the humans, hair color of the humans, hair nature of the humans, this all comes under the polygenic inheritance. More than one gene, one pair of gene is responsible for a character, it is called as polygenic inheritance. Mutations. Chromosomal aberrations means chromosomal changes, either a part of a chromosome is lost or extra copy of chromosome or extra part of the chromosome is attached to the different positions. Next, a colorblind girl will always have a color mother, brother, sister, father. So here we can remove two options. A colorblind girl will have colorblind is what type of inheritance? Colorblind is what type? Sex linked, recessive or dominant? It is present on which chromosome? Who are the carriers for this disease? Mothers are carriers. So, if a father is only colorblind, we can remove two options, eliminate two options. One is the brother, one is the sister. Mother can carrier, but not a colorblind. If daughter is a colorblind, means obviously father and mother are carriers. Mother is a carrier, father is a colorblind. Mother can be a carrier. Remember this point. C rounding up, that is indicating that she is a carrier. XC, it is rounded up. XC rounded up means she is a carrier. XC or YC or XC, it is an indication that father is a colorblind. Father is a colorblind. Don't be confused. Why? Because father will be having XY. Okay, whenever it is shown like this, mother can be also colorblind, but generally when she is a carrier, it will be shown like this, indicating with one more X. Then she is a carrier. Please, the symbols, only try to identify the symbols, and here will be showing the C. Please. Next. Next, following complement will form intersex Drosophila. Sir will discuss about Drosophila. Next, 41. The X body of Henking was observed in. So you can see the sex determination by Henking. Please find out. The X body of Henking was observed in the X body of Henking was observed in textbook. You can see the sex determination Henking. There only it will be there. Henking. Spermatogenesis. During the process of spermatogenesis, half of the sperms during spermatogenesis and other half were not having the X factor. So to honor the person Henking, it was named after the Henking as X chromosome. Next, regarding ABO blood group, if one of the parent is homozygous and the other is heterozygous, what are the chances that they will have O blood group? Okay, here try to understand the question. One is homozygous, one more parent is heterozygous. What are the chances of their child will have zero blood group? O blood group means anytime it will be how many eggs are formed and how many ovumes are formed. There is a possibility of 50%. So 50%. Next, the fruit fly Drosophila melanogaster was found to be very suitable for experimental evaluation of chromosomal theory of inheritance by Morgan and his colleagues because it is reproduced parthenogenetically. A single mating produces two young flies. Smaller female is easily recognizable for larger male. It completes its life cycle in about 2 weeks. So it is 14 days, 10 to 14 days. That is the reason it was chosen. Next, ABO blood group is controlled by gene 1, which has 3 alleles and show codominance. There are 6 genotypes. How many types in all are possible? 4 phenotypes. 4 only. A, B, O. Or study the pedigree chart of certain family given below and select the correct conclusion which can be drawn from a character. Here square indicates father, 0 indicates mother, and here 2 females are affected, 1 male is affected. Okay. Then what can be the chances? The female parent is heterozygous. The parents could not have had a normal daughter for this character. The trait under study could not be color blindness. The male parent is homozygous dominant. Mother is not affected. Here father is affected. So what can be the chance? Huh? Sorry? Female parent is mostly heterozygous. Then only it is possible. Next, because 2 daughters are affected. So then the possibility is Heterozygous. Mother is heterozygous actually. Next. Coming on to the next question, ninth question of exercise 2. When a yellow mouse was crossed to another yellow mouse, the F1 generation produces yellow and brown black mice in the ratio 2:1. The yellow mice are never homozygous. The reason is, when a yellow mouse was crossed to another yellow mouse, the F1 generation produced yellow and brown black mice. Brown and black mice in the ratio 2:1. The yellow mice are never homozygous. The reason is, homozygous yellow cannot survive due to the lethal effect of genes. Yellow mice are not very suitable to live. There is no formation of zygotes with the homozygous yellow constitution, none of them. Actually, as per the textbook, the lethal gene concept was not there, and because of the color of the skin also sometimes may affect the organisms. So here yellow gene can be, it can be lethal. It is one of the lethal because it cannot be. Here the yellow mice are never homozygous. If they are homozygous, because of the lethal gene effect, it will be died. Okay. Next, coming on to the next question, 16th question. The spread of genes from one breeding population to another by migration, which may result in the gene frequency, is called genetic drift, gene flow, gene. One of the above. The spread of genes from one breeding population to another by migration. Please underline the word migration, which may result in changes in the gene frequency. So already the gene frequency is there. So third option cannot be the option. So fourth option is also not the option. Genetic drift means, gene migration, nothing but. So gene migration is also not the answer. Only the answer is movement of flow. Next, a gene genetic. Okay. Next, 18th question. Which of the following statement is or are correct for an epistatic gene? Epistatic gene means one gene dominating over the other gene. So you might not have got this epistatis. Epistatic means one gene dominating above the other gene is called epistatic gene. Epistatic gene is non-allelic. Okay, epistatic gene never expresses itself independently. Epistatic and hypostatic genes are present at different loci. All of the above. Epistatic gene means one gene dominating above the other gene. Epistatic gene never expresses itself independently. They has to be controlled by other genes, or it will not express individually. So all of them are the options. All of the above options